In the Chapter 8 video, the third one, a question came up about the distribution. And the question was, if we have a mean of 8.2, and this is hours spent on the internet, and the standard deviation is 9.84, then obviously, according to the distribution, one standard deviation below the mean would be negative 1.64. One standard deviation above the mean would be 18.04. And the 18 hours is fine, but how do we get negative 1.64 hours? Because we're going to be looking for a 95% confidence interval, so we're going to want to include all of these values. Well, how does that happen when there really can't be values out here? So, because of course you can't spend negative hours on the internet. So the answer is that that's not really what goes on. We're using the central limit theorem here. So although this is one standard deviation below the mean, what we're really using is the standard error because we're finding a confidence interval for the population mean. So let's come over to here. So this is the actual distribution we're working with. So again, we have a mean of 8.2 that was given to us in the problem, and standard deviation is 9.84, and our sample size is 123. So we calculate the standard error, in this case, by taking the sample standard deviation divided by the square root of the sample size, and that gives us 0.887. So that's our standard error, and that's what we're using here in our distribution. And this is the t-distribution as opposed to the normal distribution. We're using the t-distribution because we don't know sigma. So in this case, when we go out to 95%, that's going to be roughly here. I think a little bit short there. So let's see, it should be a little bit short. I think in the video we get a 99% confidence interval goes from 6.44 to 9 point something. Let's see if I can find that again. 9.96. Okay, so we can see that here. We know that 2 standard deviations out is roughly 95%. And again, that's for the normal distribution, but the t-distribution is pretty close, especially with such a large sample size as 123. So, so that is the explanation for how that works. So we have to use the standard error for the standard deviation in our distribution because we're looking at the distribution of sample means rather than individual values.